Hey everybody! For today's mini lecture, which is mini lecture 15, we are taking a look at the lower Paleozoic, which are really the Paleozoic rocks in our subsurface, so the ones that we can't see here in Nebraska. Now, the other day, when we discussed the Precambrian, we had left off with the development of the continent of Rodinia. Now eventually, plate tectonics works its magic as it does, and Rodinia once again begins to break apart. So now we're entering into the Phanerozoic, which is that time span. It's broken into three eras, the Paleozoic, the Mesozoic, and the Cenozoic. For today, as I already said, we're focusing on the Paleozoic, and the portion that we're focusing on is highlighted by this orangish-brown colored box here. So we're covering the Cambrian, the Ordovician, Silurian, Devonian, and Mississippian of Nebraska. And you'll notice the Mississippian is basically the lower part of the Carboniferous, for if you're speaking to anybody outside of the United States. So as you'll have read in this lesson, we have seen this sedimentary sequence over and over and over again in the subsurface at this time frame, during this time frame. They always start with an unconformity, and if you recall, an unconformity represents an erosional surface or a period of non-deposition. So in other words, it's really just representing a gap in time. In this case, it's representing an erosional surface, which is then overlain by a basal sandstone. We refer to it as a basal sandstone because it's always at the base of the sequence, so very literal here. This sandstone is then overlain by shale, and then on top of that is usually a limestone layer. What you'll see today in your reading is that there's also this form of limestone called dolostone, which is an alteration product of limestone in typical environments, but might have been forming in a different way back then. But most of these lower Paleozoic rocks are actually dolostones. This sedimentary sequence actually reflects rising and falling sea level. So here on the left is a nice schematic representing this. You're standing in the same location through time. So let's say we are standing right here where that X is. In time 1, in A, we're in a sandy area on top of an erosional surface. That sandy area has sea level of a certain height, but let's say over time, sea level rises. If we're in that same spot, we're actually going to start to see deposition of shale because our sea level is rising. Same situation in C, we've got sea level rising further, and where we previously were has now seeing limestone or dolostone deposition. So we have this very characteristic sequence where we have our unconformity exposed to land erosion when sea level is very low. Then as sea level rises, we get deposition of a sandstone on a shallow sea slope near shore surface. And then we get deposition of shale, which represents intermediate sea level in this case, with a nearby source of siliciclastic sediments, so there has to be some sort of source from land. And then we get limestone, which is the highest sea level here in this sequence when there's no nearby source of siliciclastic sediments or sediments from land. And the main deposition is by calcareous organisms. So the Cambrian to the early Ordovician is this first part. And I'm trying to figure out how to hide my colors. Oh, I figured it out. Erase them. Okay. So we're going to start out here with the Cambrian to the early Ordovician, and these again are paleogeographic reconstructions that we're seeing here. So on the left is the early Cambrian, which is about 540 million years ago. And on the right is the late Cambrian, which is about 40 million years after that, so about 500 million years ago. During this time, you can see that Nebraska still remains in the continental interior, after that failed rifting event. The rocks that are deposited at this time, though, indicate that throughout the Cambrian, from the early to the late, rocks increasingly were submerged below sea level. So this represents the continents being submerged. So what exactly is causing this? You can see it's happening all over the globe, right? So there's different areas. We're where the red box is about, but this is happening to the east in areas, it's happening to the west in areas, all the way to the right of this map. So we're getting global rise of sea level. This spurs, or is a possibility for spurring, the Cambrian explosion, which is an explosion of life at this time. So we have trilobites, which are very abundant, and you can see a reconstruction of the trilobite outlined by my cursor here. Anomalocaris is an ocean predator that may have preyed on trilobites, which is here in the foreground top left. There are inarticulate brachiopods, which are we'll see later also in the Paleozoic lectures. Edrioasteroids, which are extinct echinoderms. Archaeocyathids, which are a type of sponge, and those are in this image, all these light blue cone-shaped features. Those are archaeocyatid sponges. And then some very interesting soft-bodied creatures are also present. So Wiwaxia is from an exceptional preservation example in the Burgess Shale, and that's shown in the bottom right here. Moving into the Ordovician, from the early Ordovician to the middle Ordovician, we're seeing sea level drop locally here. It's producing another unconformity, and so we have that erosional surface, and then we start another characteristic sequence of sandstone deposition. So that indicates that sea level began to rise again from the middle to the late Ordovician, producing yet another sequence of those rocks. Here on the left is an image of what the middle Ordovician would have looked like paleogeographically in Nebraska. And again, reference for our global context, this is the late Cambrian, we're seeing sea level rising again. Now after that final sea level rise, we enter the early Silurian, and much of the North American continent remained submerged at this time. This did change, however, in the late Silurian when sea levels once again began to retreat. If you're seeing a pattern here, that's because it's happening repeatedly. And once again, here's a global perspective of how our sea level is relating to others in different parts of the world. Now at this time in these oceans, because they were developing so rapidly and we had so much space, there was a lot of life. So this is a diorama showing a typical scene in the Ordovician and Silurian life. There were trilobites still, but of a different kind. Conodonts, which are a type of primitive vertebrate, which we'll see in another lecture as well. Blastoids, which are an extinct echinoderm, somewhat similar to crinoids, which we've seen before, and we'll see again. Rugose and tabulate corals, which are ancient corals that aren't really very closely related to the ones we see today, very different. We get what are called articulate brachiopods. There's cephalopods, which we can see in the foreground. So cephalopod here, this is an ammonoid cephalopod, which is a relative of modern squid and nautiloids. There's also armored and jawless fish developing, and eurypterids, which are a type of sea scorpion, and you can see that in the background in the top left. So now we enter into the Devonian, and the Devonian is characterized by falling sea levels, as indicated again by an erosional surface. I'm beating this pattern into you. Nebraska was exposed to land at this time, and so there was actually diversification of life onto land in the Devonian, but there was also an expansion of fish diversity in the oceans at this time. Again, here's our context. We are mainly on land, and sea level dropped globally. As you can see, the expansion of land habitat did increase. We have the diversification of fish at this time, specifically a type of fish called Dunkleosteus, which you can't really see very well here, but he is in the background in the left there. Lots of other fish. These are armored fish in this paleo reconstruction. They had an armored skeleton. Spiriferid articulate brachiopods, which are a specific type of brachiopod. Rugose and tabulate corals are still around. We have blastoids and crinoids, and then also eurypterids, again, those sea scorpions. As Devonian life moves on to land, here's a great example of how this happens. So Tiktaalik is a fossil of a lobe-finned fish, probably one of the first organisms to come onto land. So basically lobe-finned fish have fins that can support their weight to an extent where they can migrate or move on land. Since the Devonian was a time of falling sea level and perhaps relatively different climate, temporary pools might have been relatively common, and they may have needed to travel on land to get from pool to pool. This could have spawned the first amphibians. Land plants also expanded and diversified at this time, so you may not have thought about it, but land was pretty sparse. And land plants first really diversify in the Devonian, opening a lot of new habitats because those plants could be fed on by things. And these are called niches, or however you want to pronounce it, but opening of new habitats to fill. And then finally today we're looking at the Mississippian and the Lower Carboniferous. So again, here are two paleogeographic reconstructions. Left is early Mississippian, right is late Mississippian. And this is again a rise of sea level in the early Mississippian and then a falling of sea level in the late Mississippian, based off of those rock sequences. And here we are near the equator at this time. So finally, here's our Mississippian life in seas. So there's crinoids, a lot of them. You can see them throughout this entire reconstruction, and that's supported by all of the fossil evidence we see of crinoids at this time. Fishes of all kinds, trilobites of different types. There were bryozoans, articulate brachiopods. This was a time of really diverse sharks, rugose and tabulate corals, mollusks of bivalves and gastropods, and then ammonoids. And there was also life on land in the Mississippian. We get the expansion of forests and swamps, large insects, amphibians, and other early tetrapods. So just to sum it up, what we can see is that that entire lower Paleozoic time period can be summarized by changing and falling and rising sea level, basically. Low sea levels in the Cambrian, gradually increasing to the late Cambrian, then falling into the middle Ordovician, and then rising back up into the late Ordovician and early Silurian, falling once again, rising, falling, rising, and so on. And each time that sea level rises, we produce a sandstone, shale, limestone sequence. So thank you for listening to this mini lecture. I hope you have enjoyed this week's 2 lessons on the Precambrian and the Lower Paleozoic. Next week, we will be finishing up the Upper Paleozoic and heading into the Mesozoic.